right, so let's go over the implicit differentiation homework questions you guys have. You have question on number 21. And I'm going to rewrite it so I can see it better. This is 6x squared plus 3xy plus 2y squared plus 17y minus 6 equals 0. And it looks like they want me to find a tangent line at negative 1, 0. All right, in order to find a tangent line, I got to have some slope. Because I got a point, right? So how do we take the derivative implicitly? 12x plus, now we have to use what rule here? Product, right? So it'll be first, d second, which is dy dx, plus second, which is, first, second, which is y, times the derivative of the first, which is 3, plus 4y, yep, 4y dy dx, plus 17 dy dx, and then the derivative is negative 6 and 0 is just 0, right? So now we're going to factor out a dy dx and move the other terms to the right side of the equation. So we're left with 3x plus 4y plus 17 equals, now I'm going to move some things over, it's going to be negative 3y, right? Okay. And then to get dy dx all by itself, divide. So this is negative 12x minus 3y all over 3x plus 4y plus 17. And now we want it such that x equals negative 1 and y equals 0, right? Because we need the slope. So what happens when x is negative 1? We get 12 up here, and then the y is 0, right? So that goes away, and we get over negative 3 plus 17, 14, and we can reduce this to 6/7. So my tangent line at negative 1, 0 is going to be y minus 0 equals 6/7 times x plus 1, right? Did it ask for the normal? On number...
Yes.
Well, the only difference would be this would be a negative 7/6. So this would be, let me write it properly. Normal line at negative 1, 0 is going to be y minus 0 equals negative 7/6 x plus 1. All right, moving right along. I need to do the same thing except with this other function. And I'm going to rewrite this so I can see it better. 2xy plus pi sine y equals 2 pi. And the point is 1 pi over 2. So I have a point, now I need a slope. So we need the derivative, right? So we take the derivative implicitly using the product rule first because we have 2 multiplied together. So my first is going to be 2x d second, which is dy dx, plus second, which is y d first, which is 2. I don't know why I'm having trouble saying the second part of the product rule today, but it's not. Okay, so then this pi is a constant. It's just going to go along for the ride. What's the derivative of sine? So this is going to be cosine of y dy dx. Good. Equals the derivative of 2 pi, which is 0 because it's a constant. Good. Let's factor out a dy dx. And we're going to get 2x plus pi cosine y equals, and moving things over, we're just going to move over the negative 2y. So this is going to be dy dx equals negative 2 numbers and see what we get. Negative 2 times pi over 2. That's right, so we get negative pi on top. There's nothing negative about pi, is there really? Okay, fair enough. It's Friday, we're supposed to have fun. 2 plus, what's the cosine of pi over 2? 0, so this whole thing goes away, and so this is 2 times 1, which is 2. So that's the slope. So we need the equation of the tangent line at 1 pi over 2. It's going to be y minus pi over 2 equals negative pi over 2 times x minus 1. What's the only difference for the normal line? Yeah, it's going to be 2 over pi. Now the book, it puts it in y-intercept form, doesn't it? Or slope-intercept form? Don't do that, please. Just leave this. It's perfectly acceptable. There's nothing wrong with it. The AP people love it. That's what matters. And that, well, you know, college professors will like it too, I promise. So that's going to be y minus pi over 2, less margin for, you know, this is just better. There it is, okay? So they don't have like regular numbers. They've got some pi in there, right? It's okay.
Pi is just a number.
3.1415. 29. Keep going. Here we go. Andrew is really good at making these so small. All right. So I'm going to take the derivative of this y equals 2 sine of pi x minus y at 1, 0 is where I need this tangent line and the normal line. Okay, so the derivative on the left. Yeah, that wasn't a trick question, I promise. Then we have 2 goes along for the ride. Derivative of sine. Cosine keeping the argument times the derivative of the inside, which is, what's the derivative of pi x? Pi minus dy dx. Now the only tricky part about this problem, and you might not see it right away, is in order to isolate, okay, the dy dx, we have to distribute this. It looks gross, but you distribute it, and then the dy dx is free, right, for you to move over to the other side? You follow that?
Wait, why can't you just divide pi minus dy dx on both sides?
Well, I get a 1 here equals all of this over dy dx. Is that going to help us get dy dx by itself? And then we have a fraction with a dy dx in the top and 1 in the bottom, you know, so it's a little bit messier. So whenever you have something like this, you really need to distribute this. So what is this going to be? This is 2 cosine pi x minus y times pi. So this is going to be 2 pi cosine of pi x minus y minus what? 2 dy dx cosine of pi x minus y. And now do you see how I can just add this to the other side? So then we get dy dx plus 2 dy dx cosine of pi x minus y equals 2 pi cosine of pi x minus y. I can't write. Everybody got that? And now what are we going to do on the left side? Factor it out. That's right. So this is dy dx times 1 plus 2 cosine of pi divide by this? We get dy dx equals 2 pi cosine of pi x minus y all over 1 plus 2 cosine of pi x minus y. And then we go such that, right? What do we need? X equals what? 1. And y equals 0. So we need a slope at that point, so let's plug that in. We get 2 pi times the cosine of pi, right? Because the y goes to 0. Cosine of pi is negative 1. So this is going to be negative 2 pi on top. And then this has got, we already know that's negative 1, right? Because this is negative 1, that's negative 1. So this will be 1 plus 2 times negative 1. Negative 1, right? So the slope is 2 pi. So the tangent line at 1, 0 is going to be equals 2 pi times x minus 1. Normal line. It's going to be y minus 0, negative 1 over 2 pi, good, times x minus 1. All right. On 41, what do they want us to do? dy dx. So y equals 3 times the cosecant of x to the 3 halves. So dy dx here is equal to, what do we have to do? This is a power combined with a chain. So power down, which makes it 9 halves, good. Function, lower the power 1, which makes it to the 1 half times the derivative of the inside, which is negative cosecant x cotan x, yes. All right, now I can pull the negative out in front, and this is cosecant to the 1 half, and this is cosecant to the first, right? Can I add the exponents? May I add the exponents? I mean, I can, but may I? So what's 1 half plus 1? So this is cosecant. Oops, I can't write. To the 3 halves x times cotangent of x, right? I just simplified it a little bit by adding the exponents. Griffin was quoting this morning, mads, mads, mads. When you multiply, you add the exponents, you divide, you subtract. Mads. Multiply, add, divide, subtract. I thought it was kind of clever. All right, that's it, huh? Okay. So we should move along. With the document in your hand, I hope that you guys took the time to take the first derivative of the unit circle equation. I'm converting a document to a smart notebook file.
That's all we're doing today?
What?
Is this all we're doing today?
Is this all we're doing today? The answer answer is yes.
And we're going to lunch early.
No, sorry. What?
What's the message on?
The message is to the pre-cal class that had a test second block.
And they have the trig identities test.
Trig identity equations and identities tests. Yes, they did.
Oh, I get it. I should have put a message up there.
What does it say? I can't
Quit while you're ahead.
Not quit while you're ahead. Really? It says, good luck on your test. You will all be okay after a few hours. Work fast. That was from Skylar. And then Julia said, we survived this test. It will be okay.
Define survive.
We're live.
Some of us have 25 on that test.
I know, I felt like that before.
Yeah,
You
some
said
of
it
us-
really freaked me out.
Yeah, anyway. Here we go. We're going to take the derivative of x squared plus y squared equals 1. Okay, and then we get 2x plus 2y dy dx equals 0. 2y dy dx equals negative 2x dy dx equals negative x over y. Well, that's great. And then if I gave you any point, I know you can give me the slope, right? Well, guess what? We have higher order derivatives in implicit differentiation. We can take the second derivative, which means we're going to take the derivative of the first derivative to give us the second derivative. Okay, and the notation is what it looks like. The 2 is between the d and the y, and that is that way so that you don't think that you're taking the derivative of y squared. Okay? And I do not know why they didn't do that in the bottom of the denominator here, but you know what?
These calculus
We're
questions
stuck
are
with the notation that they've been using for years, and that's what it is.
Just keep us on our toes.
Yes, I guess so. All right, so we're going to find the second derivative. I'm going to put a big equals here. So we're going to take the derivative implicitly of the first derivative, which is negative x over y. So what rule do I have to use? Quotient rule. Okay, so we go ho, which is y, d high, good, negative 1, minus high, which is negative x, d ho, which is dy dx, good. All over ho ho, which is y squared. Now, before you freak out, you're going to say, Mrs. Muller, but Mrs. Muller, I have a dy dx now on the right. Does that bother you? Yes, well, it bothers a lot of people. But, alas, do we know what dy dx equals? So what can we do? We can stick it right in there, can't we? Now, before you do that, I want you to do this notation, or this algebra. Can we bring the 1 over y squared out in front, just like we brought out the 1 over h? Because nobody in here likes double-decker fractions, and nor do I. So we bring that out in front, and then what's left? Negative y, and now this is a minus, which is a plus, and then this is x times negative x over y. Everybody got that? Now, we can also simplify this a bit and get 1 over y squared times, this is negative y, minus x squared over y. Can we find a common denominator inside the brackets there? What would it be? Y. So this is going to be 1 over y squared times negative, I have a common denominator here, negative y squared minus x squared. And now let's factor out a negative 1 over y. So then I get, if I do that, what comes out? I have a negative 1 over y cubed. And then what's left in here? If I factor a negative out of the top and bring the y out, what's left? Y squared plus x squared. equation, this problem, what is x squared plus y squared equal? 1. So then I can say that the second derivative of y with respect to x is negative 1 over y cubed. You okay with that? Oh, no, you just have to remember the technique, but right? We know that it equals 1 from the original problem statement. Okay, what if it was x squared plus y squared equals 8? We put an 8 there, right? We would put an 8. But here our problem said, well, x squared plus y squared by definition is 1. So I can replace that. So that's a pretty nice, simple second derivative, right?
They're all that easy, right?
No. No, they're not. But let's do this on your calculator, because your calculator likes to take derivatives for us. Do I have a volunteer for them to bring their calculator over to the...
I got it.
Okay. Now what do we have to do? We have to rotate it.
What did I do?
No, yeah.
We're going to rotate up on the thing.
Yeah. I think, no, I think just hit 90 to the right. There we, nope, you went too far. 90, there we go, it's rotated, right?
Okay.
Now I have to,
Don't hit reset. What do I hit now?
no, just relax. Don't hit anything.
No, I don't know.
Can you type it? Can you see and type, are you sure? Alright, so what are we going to do? Oh, you're in degree mode, so let's change it mode here.
Ooh.
Because calculus is rad. Okay, alright, so what we're going to do is have the calculator take the derivative implicitly. So how do we get there? Do you remember? Impdiff, which is F3, up arrow, right? And click on impdiff, and our equation was x squared plus y squared equals 1, comma, now you've got to tell the calculator what the x variable is. X, so comma x, comma y, and close the parentheses, and press enter. And I'm not noticing that, problem of the week numbers are here on a non-calculator problem of the week, but that's okay. That's all right. They were just adding, subtracting numbers. I'm all right.
Oh,
But
no, it's not calculated. They get a 0.
no, they don't do that. Okay, here we go. Right here. That's what your calculator gives you, right? Did that match what we did? The answer is yes. Don't go anywhere. I'm going to put it up here, right? So everybody's able to do impdiff on the calculator and get the same answer, right? Okay, Andrew, you're up. We're going to do the second derivative. How do we do the second derivative? After the y here, you put comma 2. Now it gives you the second derivative. Press enter. But wait. That seems to be my phrase today. But wait. Does that match? No. Can the calculator do the thinking thing that we did that was inside the bubble? No, it can't.
It's flawed.
So, here's the second derivative. So the calculator can't do this thinking thing. So what do you have to do? Is this, let's see if it's wrong. What did the calculator do? The calculator said dy, the second derivative was this, which was negative x squared over y cubed minus 1 over y, right? That's what the calculator said? Can we find a common denominator here? It's going to be y cubed. And then this is going to be negative x squared minus y squared, right? Can we factor out a negative 1? Over, I'm sorry, we need to show this square. X squared plus y squared over y cubed. But we all know that this was equal to, so the calculator can get you the derivative, the second derivative, but it can't simplify it for you using that initial information. Okay? So let's find the third derivative now. Whoa. Third derivative. We take the derivative of the second derivative. Now, what is the second derivative? Let's refresh our memory here. Right? Dx squared is equal to negative 1 over y cubed, right? Now, can I take and rewrite this in exponential form where this is an easier derivative to take other than using the quotient rule? Right, so this would equal negative y to the negative 3. Good, Marianne. So now, if I want the derivative of the second derivative, I'm going to put a prime here. Well, I'm not yet, because I'm not ready to take it yet. I want the third derivative, right? That's what I wanted to write. So what do? We go power down, which is negative 3 times negative 1, which is 3y to the negative 4th times dy dx. But wait, do we know dy dx?
Yeah.
We do. What did we say it was before?
Negative x over y.
So I'm going to rewrite this as 3 over y to the 4th times negative x times y. And we get negative 3x over y to the 5th. All right, that's what we're going to say that the third derivative is, which is jerk, right? Now, let's see, Andrew, what the calculator gives us for the third derivative. How are we going to do that? We're going to arrow over and then say instead of 2, we're going to put 3.
The expanded thingy.
It's expanded, but what did the calculator give us as a gift?
In the parentheses.
In the parentheses, it tells us x squared plus y squared, which we all know is 1. So did it match? The answer is yeah. I mean, it's so amazing that I can put this in the notes, isn't it? I'm just appreciating technology here. Whoop, I didn't want to do that. Undo. I wanted to use a brighter color, right? We know that this is equal to 1. And it matches what our derivative is, right? Our third derivative. So questions on how to take the second derivative and the third derivative. What if you wanted the fourth derivative? You would just use the quotient rule one more time, right? And if you wanted to do that on your calculator, you would use the command comma 4, right? I don't recommend going much beyond 10, or else the calculator's going to, you know, say leave me alone for an hour or 2 or 3 or 4. Okay, while it's calculating. All right. I figured let's do some free response questions from the AP exam, and these were the first 2 I came to. 1978 and BC1. So you can, we'll have it set up if we have to go back, right? So I handed you the sheet, right? You got this sheet? So you don't have to write the question out. Now this is from 1978, which says 1978 AB5 BC1. 1. This means this question was both on the AB exam and the BC exam. It was number 5 on the AB, and then it was number 1 on the BC. So that was the first question they saw. But guess what? We can do this question now. So let's try. It says, write a general expression for the slope of the curve. What does it mean when it's asking for the slope of the curve? The derivative, right? Because derivative is synonymous with slope. So this is asking you for dy dx, question mark. And it's an implicitly defined function. So how are we going to find that derivative? By taking the derivative implicitly, right? So what's the derivative of x squared?
2x.
2x. Now we have to take the derivative of our product. And I always use my first term as negative x. So I distribute the negative without thinking, without trying. So that's going to be first, which is negative x, d second, which is dy dx, plus second, which is y, times the derivative of the first, which is negative 1. Good. Plus, the derivative of y squared is 2y dy dx. Great. And then the derivative of 9, we're really happy with, is 0. Now we're going to solve for dy dx by factoring it out first and moving some terms to the other side. So we're going to have negative x plus 2y inside the parentheses here equals 2, or y minus, right? Y minus 2x on the other side. And then we get dy dx equals y minus 2x over negative x plus 2y. There you go. That's probably 2 out of the 9 points. That's good.
Yeah, 5.
All right. So what does part B say? It says, find the coordinates of the points on the curve where the tangents are vertical. So how do we know when we have a vertical tangent? When the what kind of when the denominator is 0, right? Because the undefined slope. So vertical tangents occur when dy dx is undefined. And when does that happen? Right. And that's when the denominator is equal to 0. So that means negative x plus 2y has to equal 0. So solving this for one of the variables, so x has to equal 2y. Do you agree with that? Yes.
So on the actual AP exam, will we need to like write?
I would tell the, because what you're trying to do is communicate to the grader or the reader of your answer that you understand calculus. So I always like to tell them what I'm doing. I'm saying, well, so when this question says find the coordinates of the points on the curve where tangents are vertical, well, you can say vertical tangents occur when the derivative is undefined. And then you can go about the algebra to do that. And so that you communicated that you know the calculus. Do you see? Yeah, so I would love it if you wrote that. It's going to make it a stronger answer. All right, now, but this isn't the points, the coordinates of the points. This is just a relationship between x and y. So what has to be true? Well, this has to be true, and the points have to be on the curve. Well, what is the curve equation? Right? So the xy has to satisfy this, and it has to satisfy this. So this is a system. How do we solve a system? Substitution. so wherever we see x, we're going to put what in its place?
2y.
2y. So this is going to be 2y quantity squared minus 2y times y plus y squared equals 9. So let's simplify that a bit. We get 4y squared minus 2y squared plus y squared equals 9. 4 minus 2 is 2. So this is equals 9. Y squared equals 3. Y equals plus or minus root 3, right? So now I have to find the points. So if y is root 3, what is x? Because we know that x equals 2y. So that x is y, 2 root 3, good. And then the other point's going to be when y is negative root 3, negative 2 root 3. So these are the coordinates where the tangent lines are vertical. So do you believe that?
Sure.
Ted's going to help us out here. So let's type in, what is our equation? X squared minus x times, you got to use the times. Plus y squared equals 9. There it is. What does that look like? An ellipse, yes?
Yeah.
Remember, our ellipse was x squared plus y squared equals 9, right? That would be when the horizontal, when it would be like this. What does the xy term do to it? It rotates it. All right, so let's put our points up there in line 2. Let's put our, we had parentheses, we had 2 times the square root, which is down here. Square root of 3, arrow over a little bit, and then comma, root 3. Enter. Oh, you did that already. Next point. What was our other point? Negative? Whoops, you need parentheses. Or you could just copy and insert a
It might be too hard.
parentheses. No, not there. Sorry. It's a lot of pressure, isn't it, to type in public?
Yeah, we're doing that.
Negative. Negative root 3, good. Now, let's do line 4. What would the equations be for those tangent lines? Well, y is going to be crossing the y-axis. X crosses the x-axis. So it's going to be x equals 2 root 3. Okay, and then another next one's going to be do you see how that works? All right, will you click on the points, you know, like over here? I don't know why they don't do the points that they do it in decimals, I don't know. All right, so what I'm going to do is put this in your document. So it worked, didn't it?
Yeah.
It worked, yay, hooray. But we only, so that's probably 6 points out of 9, right? Or 7 points out of 9? So we need 2 more for a perfect score on this free response. So let's do C. What does C say?
At point 0, 3, find the rate of change in the slope of the curve with respect to x.
What what is this? This is the rate of change of the slope.
That is the next rate.
It is the next derivative. It's a second derivative. So we got to take the second derivative. So we got to take the derivative of that. We have to take the derivative of this.
Ooh, that's not a nice looking.
Let's see. I'm going to make it smaller just so we can see it. So for part C, I'm taking the derivative of this. What rule do I have to use? Using the quotient rule, we're going to get what? The second derivative of y with respect to x is going to equal ho, which is? Yes, sir.
Before you do that, can you explain why you're doing the second derivative?
Okay, sure. The question says, at the point 0, 3, find the rate of change. Rate of change is what? Either instantaneous rate of change or average, but it didn't specify. So if it doesn't specify, it's instantaneous. Find the instantaneous rate of change in the slope. So I want the,
So that equation is for the slope.
yes, you want the rate of change of the slope. So you want to take the derivative of the slope equation. That's good. So we say ho, which is negative x plus 2y, di, which is
dy dx.
dy dx
Minus 2.
minus 2 minus high, which is y minus
2x.
2x times the derivative of the bottom, which is negative 1,
Plus
2 dy dx. All over negative x plus 2y squared, right? Wow, that looks messy, but Mrs. Muller, I got to do dy dx on the right-hand side. That bothers me, but do I know what dy dx is? Now, yes, that's the face. Mary Ann made a face that was like this. Right? She didn't want to do that. She doesn't want to plug this in. Do you?
No.
No, and we have a limited amount of time on the AP exam, so we don't want to do that. There's an easier way. Did they give us a point? So I can go such that x equals 0 and y equals 3. Can I have to simplify to plug in the points? You okay, Julia? Yes. Okay. Do you? No. So let's see what we come up with. D squared. Whoops. Yes, and I would have come up with a face like that too. This looks like somebody's prying your hair. I'm gonna fix that. There we go. I need a bit more emoji, right? That has. It's like, no, I don't want to do that, right? Okay, so what is x? 0. So let's get rid of. So we know x is 0. This goes to 0, and this goes to 0, right? That's nice. So 2y, y is 3. So what is this first? 6. Times, well, dy dx at 0, 3. Is there a way to find that out?
Yeah, we can do that.
So what do we get? We get y, which is 3 over 0, 6, which is 1/2. So that's going to be 1/2 minus 2 minus 3, and then times negative 1 plus 2 times 1/2. Which, what happened to the right side of this thing instantly? And this is going to be 2 times 3, which is 6 squared here, right? What happened to this? This is 1 plus 1, or negative 1 plus 1.
0.
This went to 0, which means this whole term went bye-bye, which was really nice. And so I can cancel now one of these 6's. I'm left with 1/2 minus 2. That's 1/2 minus 4 over 2, or negative 3/2, divided by 6 over 1, which is equal to negative 3/2, times 1/6, which is negative 1/4, is the rate of change of the slope at 0, 3. Now, if I bet that in 1978, when the AB and the BC folks took this, 60% of the population, or higher, took this and did what with it? Stuck it in here. And, their brains were exploding, right? But you have a point. But you have a point, right? So you can, they're not asking you for the second derivative simplified, they're asking you for the rate of change of it at a point. So you can plug it in, right? And not go crazy. Okay? But I'm telling you, I bet you the majority of the population had this expression and thought, oh my gosh, I got to plug that in.
Because they didn't have a teacher like me.
Right. That's very nice. All right, so moving on.
We don't have to do that.
Hmm?
It's a BC problem.
It is a BC problem, but guess what?
More AB.
There are AB problems on BC exams.
Where are there BC problems on A, B, and C?
No, there aren't. There aren't.
So, I think
But
this
I'm
is-
going to make you feel more confident because you can do a BC problem. Let's do this. You got this. Obviously, part A, anybody can do. We've got to find the derivative of that implicitly. We can do that.
Only like 60 seniors can do that. No one else can do that.
All right, so it's y cubed plus 3x squared y plus 13 equals 0. So let's take the derivative implicitly for part A. Yeah, we can do it together. I mean, we don't have to do it separately. Yep. Plus, now we have to use what rule? Product rule. So it'll be first, which is 3x squared, be second,
1. Or do I do it?
y dx, good, plus second, which is y, times the derivative of the first, which is 6x. Well, what's the derivative of 13? 0, and so we can just say this equals 0. Excuse me. Let's factor out a dy dx. And we're left with 3y squared plus 3x squared equals what? I'm going to move the negative 6xy to the right side. And dy dx equals negative 6xy over 3y squared plus 3x squared. And we can reduce this, can't we, if we divide every piece of the equation by 3? What would it look like? Negative 2xy over y squared plus x squared. Now I know we're going to think, right,
It's
that's not 1 because
No, it's 1. It was 1 earlier.
that doesn't mean it's always 1.
Why is that?
It's not wonderful.
That's not wonderful, you're right. But did our original problem statement state anywhere that x squared plus y squared is 1? No. So if we found this expression, we could put 0 in its place. Do you see? X squared plus y squared is not always 1. Or we would have only the unit circle, right? Not multiple.
Wouldn't that be nice?
Wouldn't that be nice? Okay. All right, well, there's the derivative. That was easy. Part B says find the equation for the line tangent to the curve at the point 2, -1. So they gave us a point.
Just plug it.
So we need dy dx at such that when x is 2 and y is negative 1? Yes. So how do we do that? We're going to get negative 2 times 2 times negative 1? 4, I'm sorry, yes. Over 1, 5. All right, so what's the tangent line? Y plus 1 equals 4/5 x minus 2. There you go. So Ted, let's do this on Desmos real quick and then we're done.
This guy.
Yep. Minimize that. Nope, we don't need any of those. So we get y cubed, you've got the equation right there, right? And everybody, while he's typing this in, right, knows how to find the implicit derivative, right, on your calculator. Right? And this implicit second derivative and third derivative, if you wanted it. Yes. Now, while he's typing this in, there's one other thing I want to show you. So, x times y, right? Kind of a cool looking curve, right? At what point did we want the slope at? Okay. We're going to click on that. There it is. And then what was our tangent line? It was y plus 1. No. Y plus 1 equals 4 divided by 5, right? Was it 4/5? Oh, come on. He's going to be ornery. There we go. All right, fair enough. All right, I want to show you really quickly, if you don't, I know you won't mind because it's kind of a good thing to know how to do. All right, if we go back to this question here, and remember we had to solve a system here, didn't we? Okay, Andrew, I need you back over there. We're going to solve the system, right? Using the calculator. Let's say it was a calculator active question, all right? So I want everybody to go back. Remember that you have this, right? You just flip your page over. Andrew's in position, which is great. Okay, so there we go. So clear that out. And we're going to solve a system, right? So we're going to solve what equation? How do we get to solve first? F2, 1. And we're going to solve our original equation, which was x squared minus x times y. Is that right?
Which one again?
We're going to solve this one. Okay. X squared minus x, and you've got to use the times here. Yep, y plus y squared equals 9, comma, we're going to solve this for y. Because do we know what x is? So close your parentheses, such that bar, x equals what did we say x was? 2y. Press enter. Boom. How nice is that?
It's real nice.
Whoa.
And then you could clear that out and go x equals, or no, go 2y. Because we know x is 2y, right? You could go 2y such that y equals root 3. There. So if it was more complicated, right? I mean, you know, obviously
Yeah.
that's really easy to do. But if it was more complicated, if you have what x equals, you can just, you know.
Cool.
Who likes that? Let for the record show everyone's hands were up, including mine.
My hand was not up.
Yes, your hand was up.
It was not. Patrick did not participate in the hand up as well.
New. All right, just a friendly reminder, right? Today is Friday.
Thank
Which
you for reminding
means?
me.
Half of the week, so you got plenty of time, right?
Hey, Patrick.
You do.